So let's wrap this up by practicing what we've learned, taking a look at three equations. I've written the first of them down here. Now would be a great time to pause your recording and give it a shot yourself before we work through it together. Okay, I'm just going to scroll up a bit. Oops. So we have a situation where we have a single logarithm here. We've got the variable x buried within the logarithm. So I'm going to use our technique where we convert a logarithmic equation to an exponential, the equivalent exponential, by moving the base to the other side, and then the -1 gets bumped up into the exponent. So if you take a look at that, it momentarily looks a little weird until you realize that this is just 1/5. So yes, we're heavily in fraction land here, but we're just going to have to live with that. So we're going to have that 2x is equal to 1/5 minus 1. 2x is equal to 1/5 minus 5/5, so minus 4/5. So x is going to be that divided by 2, which is -2/5. And if you'd like to write your solution set, then there you go. If we wanted to check it, if we put in 2 times -2/5, we get -4/5, plus 1 is 1/5. And then the exponent on our base 5 here. What exponent on 5 gives 1/5? Why, it's -1. That's our right-hand side here, and we see that it checks. Now I'm going to pause this recording for a second. I'm going to scroll down and write out the next equation. Okay, so here's our next equation, which is log base y of 2y plus 5 is equal to log base y of y plus 10. So this would be a good time to stop the recording and try this one yourself. Otherwise, I'm just going to go ahead and solve it. Notice how we have log base y on both sides. So again, remembering that if log base a of m equals log base a of n, then m equals n, we can say that the argument of each of these logarithms, which is in this case 2y plus 5, is equal to the argument on the other side, which is y plus 10. Solving for y, bringing the y over, we get then that y is equal to 5. And again, checking this one, I'm actually going to write out the check. Oh, I should probably, since I've been writing solution sets, do that here. If we wanted to formally write out our check, notice we're going to have log base 5 of, so what's 2y plus 5? 2y plus 5 is 15. And that's a number you could figure out on your calculator, but it's really unnecessary when you figure out that the right-hand side is log base 5 of 15 as well. So this sucker does check. Now I'm going to pause, scroll down, and write out what our final equation for this section is going to be. So here's our final equation of this section. We've got ln x plus ln of x plus 4 equals ln of x squared plus 24, all in brackets. And what we'd really like to do is have a single ln on the left-hand side and a single ln on the right-hand side, so that when the the logarithms have the same base, then you can simply match the arguments. But we can't do that yet because we have two logarithms. We have a sum on the left-hand side. The nice thing here, though, is that if you take a look at the left-hand side, you'll notice we can use our good old product rule. And the product rule says that when the bases of the logarithms are the same, that this becomes the logarithm of x on x plus 4 is equal to ln of x squared plus 24. Notice now we have the situation where we've got a single log on both sides with the same base, so now we can match the arguments. X on x plus 4 is equal to x squared plus 24. Multiplying through, we get x squared plus 4x. Using the distributive property, which we also studied in logic, it has a very similar situation for Boolean algebra. Notice how here, when we try to collect all of our like terms, our x squareds here are going to cancel, leaving me with 4x is equal to 24, so x is equal to 6. So if we take a look at how this would work in terms of checking it, you'd probably also have to either do this on your calculator or backwards use the properties of logarithms to help you out here. So if we were to do that, let's just write our little check out here because it's a little less obvious. Just going to scroll down a little tiny bit. So our check would be ln of 6 plus ln of 10 is equal to ln of, and we're going to have 36 plus 24. Notice how the left-hand side we can use our product rule to get the ln of 60, and then on the right-hand side 36 plus 60 plus 24 is equal to 60, and again we get our check, and so we're done.